All right, let's see what we've got going on in this review that we're doing today. Now, the first few problems will be going over exponent rules. Okay, these are problems that are dealing with numbers and letters, which we call variables, and exponents. Now, we have exponent rules because exponents for the variables do a different operation, like multiplication, addition, subtraction, than what the problem is like explicitly telling you to do. So that it has its own set of rules. And the first rule that we are going to go over here is our product rule. Okay, product, that word means to multiply. Okay, so it's going to look like a multiplication problem. Just like our first example where it says simplify 6x cubed times x squared. And again, I know that I'm supposed to multiply because parentheses wrapped around each of these terms does mean to multiply. Now, what gets multiplied? Now, if you had me for Algebra 1, I would always say the regular number does the regular thing. So in this problem, who would we call the regular number? Well, the regular number is our coefficient. That's the number in front of the variable. So that would be 6 in this problem. And 1 technically is in front of x squared. Those are the only things that get multiplied in this problem. So 6 times 1 equals 6. Then I get to my variable, my letter x. Okay, we have a common base. We call that our base. A base is the variable that is, or the part that's touching the exponent. And that common base, x, I'm going to write it down. Now, what do I do with these exponents, 3 and 2? Now, a lot of people want to multiply them because the problem is saying to multiply, but we can't do that. If the problem says to multiply, we do something different for our exponents. And what is that different thing that we do for them? If you remember, it is adding. Okay, so regular numbers get multiplied, but in this situation for product rule, we add the exponents. 3 plus 2 is 5. I don't have any other variables, so this problem is done. Simplified, this is 6x to the 5th. Okay, so we'll just keep working through with these examples. Okay, this next problem, I have b to the 6th times b to the 4th. Now notice in this problem, there are not any coefficients, so I don't have to worry about multiplying them. I just go to my common base, which is b, and then I deal with my exponents, 6 and 4. Now again, we don't do 6 times 4. That would be a big mistake. We'd get the wrong answer there. We can't multiply the exponents. When it says times here, it means to add up top. So 6 plus 4 is 10. The answer is b to the 10th power. Moving on. 1b here, we have 3a to the 4th times 5a cubed. Okay, it does say to multiply here. That's what that multiplication dot means. And who gets multiplied? The regular numbers, 3 and 5. So we're going to that's our starting place. If we have coefficients, 3 times 5 is 15. Okay, I have one type of variable, one base, which is a. Write it down. And then for my exponents, I have 4 and 3 times in the middle, add up high, or add up top, however you want to think. So 4 plus 3 is 7. My answer is 15a to the 7th power. Okay, next problem that's similar, that has product rule, is I have 1/3 times 2a cubed b times 6b cubed. Notice this is 3 separate terms, and that's fine. 1/3 is still a coefficient. Fractions can be coefficients. They're not in the exponent position, so I'm going to use it in the same way. I'm going to do 1/3 times 2 times 6, which would be 4. So that's our coefficient here. Okay, half or 1/3 times 2 times 6. Use your calculator if you're not sure. That's always fine. And then I have two different variables here. I have a's and b's. So I like to go alphabetical. That's just standard procedure here. So we're going to write down a first. And then I'm looking, how many a's do I have? I have a cubed, I have a b, and b cubed. So I only have a cubed. There's nothing to add to it. Now what I like about product rule, it really is about counting how many you have of each type of exponent. So I had a cubed, I had 3 a's basically, and added no more to it, so it's staying a cubed. Then I move on to my b. How many b's is this one right here? Doesn't have an exponent. Remember in math, if like you see one of them, That's the implied like coefficient or the implied exponent. That's really b to the first power. I have 1b. You can see that there's 1b there, so they don't have to put that exponent there. That's just how it works. And then we have 3b's here. So that's why we're adding these together. 1 plus 3 makes 4. So b to the 4th power. And that's done. Okay, now moving on to our next rule. Okay, our next rule coming up is the power rule. Okay, the power rule is when we have an exponent on the outside of the parentheses like we do on number 2. We have 5x inside the parentheses raised to the 0 power. So I'm going to keep saying this. The regular number does the regular thing. Our regular number is the coefficient. That regular number here would be 5. So 5 is being raised to that outer exponent of 0. When we get to our variables, we multiplied the inside exponent to that outside power. So for x, we're doing 1 times 0. Now, many people get confused. What is the meaning of a number or anything raised to the 0 power? A lot of people think that it's supposed to be 0. That is false. Type it into your calculator if you're not sure. Anything, whether it is a number, a coefficient, a fraction, anything, or a variable, it is always equal to the number 1. So 5 to the 0 power is 1. Now, for x, basically here we've got 1 times 0 is 0. The exponent is always referring to how many of that exponent that we have. So right here, when we say x to the 0 power, we're saying there are 0 x's. That means we don't got any left. So what is the value of 5x all being raised to the 0 power? It is all 1. Pretty nifty. Hey, number 3. We are asked to simplify x to the 4th power all being cubed. Okay, notice we do not have a coefficient inside the parentheses. So we have no regular number to raise to the 3rd power. Or we do, 1, but 1 cubed stays 1. So we take our base of x, we take the inside power, 4, and we multiply it to the outside power, 3, because power rule tells us to multiply exponents. Okay, so what is 4 times 3? 12. This simplifies to x to the 12th power. Okay, furthering this with a few more examples. On 3a, we have 2w cubed. Inside the parentheses, all of this is being raised to the 6th power. So my regular number in this situation is that coefficient of 2. It's getting raised to the 6th power. Now remember, an exponent is telling you how many times you are multiplying a certain value times its own self. So 2 to the 6th power means 2 times itself, 2 times 2 times 2 times 2 times 2 times 2, 6 times. Okay? And then for my variable, I keep my base, I take my inside exponent, and I'm going to multiply it to that outside power. So what is 2 to the 6th power? If you don't know that off the top of your head, use your calculator. That is 64. That's our coefficient. Then w is raised to the 3 times 6 power, which is 18. And that is simplified. 3b. Okay, we have negative 4x squared, all inside the parentheses. All of this is being squared. It's all being multiplied by its own self. We talked about this a lot in the past. That negative 4, when you have a negative number inside parentheses and then it's being squared, what that means is that we have negative 4 times negative 4. So that is a case of two negatives, a negative times a negative, which at this point we all know equals a positive. That is positive 16. Okay, and then for x, I have my inside power of 2 multiplied by the outside power of 2. 2 times 2 is 4. So this is positive 16 to the x to the 4th power. Now a little shortcut. When there's a negative number inside parentheses, okay, negative, let's say like negative 2, and we have an even exponent, it's always positive, the answer, whatever it is. Okay, if we have a negative number inside parentheses and we have an odd exponent, it's always going to be a negative answer because it takes 2 to cancel out. And odd numbers always have 1 left over. So there's your little shortcut. Okay, 3c. Okay, I have 1/2 x to the 4th. All of this inside the parentheses being raised to the 7th power. Just like I said a minute ago, okay, fractions are still coefficient. That whole 1/2 value is being raised to the 7th power. It's 1/2 times 1/2, 7 times. I take my base of x, I take my inside power of 4, and I multiply it to the outside power, 7. So what is 1/2 to the 7th power? It's 1 over 128. And then we have x. Now notice the x is not in the denominator, it's off to the side. X to the 28th power. Okay, so how do you tell the difference between what we did on the last side? Product rule and power rule. Product rule, there are no exponents on the outside of the parentheses. Power rule, when we are supposed to multiply those exponents, see all of these had a power on the outside parentheses. If you looked at our last video, okay, over here, our last slide, okay, even if there's parentheses, we had no exponents on the outside of those parentheses. That was product rule, and that's when we multiplied coefficients but added the exponents. So you have to notice those subtle differences between the problems. Okay, the next set of example, the next rule that we have. Okay, I love quotient rule. This is quotient. Quotient means to divide. Okay, quotient is when we have a division problem. It can be done with just variables or coefficients as well. I have a to the 7th divided by a cubed. I like it better when we have the first one in the numerator. So a to the 7th over a cubed. Quotient rule, okay, this is when we subtract exponents. Okay, now remember, regular numbers will do the regular thing. If I have coefficients, they're going to be divided, but exponents always follow a different pattern. And we usually do top minus bottom unless it's going to give us a negative exponent, which we will get to later on in these slides. Okay, but that is normal standard. Keep your base, and we're going to have 7 minus 3 to make this a to the 4th power. Basically, we're canceling out on a 1-to-1 ratio here. I had 7 a's in the top, 3 a's in the bottom. They have 3 in common. Okay, we're canceling out 3. We're left with 4. And on 4a, you'll see that we're doing that for common like variables. I have x to the 20th, y to the 9th, z squared over x to the 5th, y to the 9th, z. Okay, and what's that exponent for z? It's 1. So we're just matching up those common, okay, variables. For x, okay, I keep that common base. I write it down once, and I'm going to do 20 minus 5. We're subtracting. So I have x to the 15th. Okay, now look at my y's here. Okay, well, let's talk about it, and we'll do a little shortcut later. I have 9 minus 9, which is 0. Okay, you can write that down for a placeholder at first if you forget about it, but really, what does it mean when we have y to the 0? It means I have 0 y's. X to the 15th means I have 15 x's. I want to keep that. But if I have 0 for something, I don't have to write it down. I show that I have 0 of it by not having it be part of the problem at all. And then for z, 2 minus 1 is 1. You can put the exponent, you don't have to. Just whatever makes you look really happy. So we don't ever leave a variable raised to the 0 power as our final answer because, again, it's not there. So I'd write my final answer as x to the 15th z, and that would be done. Okay, for 4b, okay, here's where we have coefficients. My coefficients, okay, my pen's not working. My coefficients here are 14 in the numerator, 7 in the denominator. So we just divide numerator divided by denominator. 14 divided by 7 is 2. And then we shift gears a little bit. Okay, remember, because we're not going to divide our variables exponents, we're going to subtract. So for r, we have 2 minus 1, which is 1. I can leave it just as r if I would like. And for s squared, take away an s, I have just 1s as well. So our answer here is 2rs. Okay, for number 4c, I have 36 m to the 9th n to the 5th over 54 m cubed n squared. Now notice my numerator 36 is smaller than my denominator 54. We don't ever want to have decimal answers, okay, in these situations. We're just going to simplify the fraction. If you're not sure if it simplifies, how it works out, just type it in as a fraction. 36 over 54, Well, this simplifies to 2/3. And then from there, I'm going to simplify my variables. I have m. I'm going to do 9 minus 3, top minus bottom is 6. And then for n, we have 5 minus 2 is 3. So 2/3 m to the 6 n cubed. So I really like quotient rule, pretty straightforward. We're just divide our coefficients, subtract our exponents. Okay, moving on. Okay, express 2,485 in scientific notation. Okay, so scientific notation, we don't use it a whole bunch. Should have been really hit in middle school, but when we have scientific notation, the rule is you are only allowed one whole number in front of the decimal. So if there's not a decimal, it's implied at the very end of a number, and we're going to count and move it, in this case, to the left until only one number is in front of the decimal. So 1, 2, 3. Okay, right here. 2 will be the only number in front of the decimal. So awesome. So we would write this now as 2.485, and notice we didn't lose like any numbers, we just moved where the decimal place was at. And then scientific notation is always written as a times 10, and then we moved it to the left, and when we move it to the left, we add an exponent for every space that we move the decimal over to the left. There's an acronym called LARS, which stands for left, add, right, subtract. So we moved our decimal 3 places to the left, so we're going to add 3 to our exponent. Now you can always check scientific notation on your calculator. If I typed in 2.485 times 10 cubed into my calculator, I would get right back to that original problem. So scientific's pretty awesome. It's just a different way of writing out the same problem. You're not changing its value. You're just giving it in a different way. It's like saying hi and hola. They both mean, hi, hello, but we're saying it in a different way. Okay, 6, 7, and 8. I'm not going to waste video time going over there. These, use your calculator if you're not sure how to do that basic integer operation. Okay, awesome. The next skill on our review is to multiply two binomials. Now, if you remember, a binomial is two terms that are grouped together. And when we multiply two binomials, we're using a method called FOIL. And FOIL just stands for the order in which we multiply: first, outer, inner, last. Hopefully you guys all remember this skill. You probably used it in geometry as well when you're multiplying out sides lengths of shapes. But for x plus 2, we're multiplying it times x plus 3. Again, 1, 2 times 1, 2 terms, binomial times a binomial. We start with our first, x times x. Remember, this does not, a lot of people want to say like 2x. Okay, not 2x. We are multiplying x to the first times x to the first. I'm adding my exponents here, so I'm x squared. Okay, different where that 2 is placed. And then we're doing our outsides, x times positive 3. Now watch your signs. That's positive. That 3 is a regular number. It's a coefficient. You can see how it's all big. It's like wanting its place. It's going to go in front of that x. That was our O, outer. And then we're going to move, and we're going to multiply our insides, 2 and x. Okay, 2 times x is positive 2x. And then last in each set of parentheses would be positive 2 times positive 3. Now, that's positive 6. And don't forget, we talked a lot about this in Algebra 1. This is not positive 2 and positive 3 to make positive 5. We're not adding them together just because they have plus signs. The parentheses touching between these two sets of binomials means that we multiply all the way through. And remember, that really special thing that happens when we FOIL out two binomials is that the middle two terms should be like terms. Okay, that means they had the same variables, so that means we can add together their coefficients. So we have x squared. There was no other squareds in here, so no like terms to go with it. Our middle two, 3x and 2x's. If I have 3x's and 2x's and put that together, then I have 5x's and then plus 6. So a lot of times when we multiply out, or when we FOIL, we get 3 terms in our answer. Not every time, but a lot of times. Okay, so number 9a here. We're FOILing again. Let's see, 2 terms times 2 terms. See how my parentheses here are touching? That's letting me know that I need to use this FOIL method. Okay, and for some reason, I can't erase. There we go. because I was using my finger. So we have 4x that we want to multiply. We're going to go 4x times the first term in the next set, x, and we get 4. See, 4 times the coefficient here. 4 times 1 is going to stay 4. Then we write down x. X times x is x squared. Then we do outsides, 4x times 3. So 4 times 3, those regular numbers are getting multiplied. 4 times 3 is 12. X, hey look, no x is attached to that 3, so it's just going to stay 1x. Then we're going to do our insides. Now notice this is a -7. Remember that a number sign, like a value sign right in front of a number or variable, it stays with it. Okay, so -7 times positive x is going to stay -7x. And then I have -7 times a positive 3. A negative times a positive stays negative. So -21. I look for my like terms. Again, they will be in the middle. So I'm left with 4x squared, positive 12. Okay, positive 12 minus 7 leaves me with a positive 5x minus 21. Okay, that one's done. 9b. Okay, I need to FOIL again. And remember, parentheses right here, they're attention. They're telling me to multiply. I'm going to take first terms in each set and multiply them. 8h times 3h. Now notice they each have a coefficient, an 8 and a 3. We just multiply them together. 8 times 3 is 24. H times h is h squared. And I multiply my outsides. That 8h, it needs a term getting multiplied to a -1. So that becomes -8h. Didn't change the variables there. Then my outsides, or insides, because we're foiling, and my pen keeps changing. Now I have -3, okay, -3 times positive 3h. So my coefficients are -3 times positive 3, that's -9. 1h is the only h I can see is 1h, it's staying. And then -3 times -1. So here's where I'm watching that sign change. Negative times a negative is a positive. Now notice I only have that 1h squared valued right here, so it can't combine with anything else. Nothing else has an h squared. So we have 24h squared. My middle two terms both only have 1h. They're like terms. So minus 17h, that's what -8 and -9 combine to, and then positive 3. Okay, I think you guys should all be great on foiling. Okay, moving on. Number 10. Now, we did talk about this a lot in Algebra 1. Let's see if you guys remember. Here's what a lot of people like to do when they see this type of problem. They're like, x minus 5 squared. Bam, I got this. This is just going to be x squared is x squared. -5 squared is like, heck, I even remember Miss Larson told me if a negative's inside parentheses and I square it, it's going to be a positive 25. Bam. I'm so awesome. Sad thing is, this is wrong. Okay, we cannot just go through and distribute that outside exponent and square everything inside of it. That's not how it works. Unfortunately, it would be really easy, but it's not. Remember, when we square a value, squaring means to multiply. Okay, this squared means to multiply a value by its own self. So what that means, I have to take what's inside the parentheses, x minus 5, and multiply it by its own self, which was x minus 5. So you need to remember that this squared means 2 of what it was ever inside the parentheses being multiplied. So now I FOIL this piece out, and I have x times x, which is x squared. X times -5 is -5x. My insides, I have another -5 times x is -5x. And yes, I do have 2 of those values. And then I have a -5 times a -5, which is positive 25. So it's similar to that shortcut I want to take, but the insides do not cancel out. -5 and -5 combine to -10x. So the answer here is x squared minus 10x plus 25. Okay, similar to the shortcut over here, but it was missing that middle piece, which will mean you get it all wrong if you take a really bad faulty shortcut. Okay, so remember what squared means. So furthering that example, if I have a plus 3b all being squared, okay, that means to take that a plus 3b and multiply it by its own self, another a plus 3b. And notice I have two different sets of variables. Foiling still works. Just follow that process of first get multiplied. A times a is a squared. Again, that's our product rule. I'm adding those exponents of 1 plus 1 to make a squared. Then a times a positive 3b. Well, 1 times 3 makes this positive 3. And a times b, notice they are different variables, so I don't change the exponents. When I multiplied two different variables together, like a and b, I just mush them together side by side in alphabetical order. Okay, then my insides get multiplied. 3b times a. So again, 3 times 1 is 3. b times a. Two different variables. I'm going to mush them together, but keep them in alphabetical order. I can rearrange them like that. And it means the same thing. And then last, 3b times 3b. 3 times 3 is in positive 9. Now I do have a common variable, b times b. Keep that common base. I have one b here times another b here. We add those exponents. 1 plus 1 is 2. Again, because I FOILed, my inside two terms should be like terms. So I bring down my a squared, 3ab's plus another 3ab's. Remember, when we combine like terms, when it switches to addition or subtraction between terms with the same variables, we only add the coefficients. 3 plus 3 is a positive 6. Addition and subtraction cannot change our exponents. It stays ab. Notice the way I was able to change these exponents up here was because the problem called for multiplication. At this point right here, it's addition between the two values, and we cannot change the exponents. Addition and subtraction does not have the power to change the exponents. Okay, so hopefully you'll remember that, and then bring down plus 9b squared. No more like terms. That's our final answer. Okay, moving over. Ooh, fun. Okay, solve the inequality of negative 2x plus 3 is less than or equal to 11. Now, when we're solving an inequality is, one of these signs right here, not an equal sign, greater than or less than sign. We do treat it like an equal sign. Okay, and I've always told you guys when you're solving equations that you need to find where the equal sign is at, or the inequality, because if we move any values across that line or to the opposite side of that line, we use opposite operations. If we're doing things in a problem that are where they're on the same side, then we use the same signs that they already have. Okay, we don't have to do the opposites unless we move across that line. So if I have negative 2x plus 3, it's less than or equal to 11, I'm trying to get x by itself on the left side, and that's important because we don't know the true way to graph an inequality unless x stays on the left side. So remember, underneath we have some more complex, but I do not have any multiplication. I do not have any like terms to combine. So when we get to the point where we do not have anything left to expand and then simplify, we start trying to isolate our variable. And when we isolate, we are using backwards PEMDAS. So we move by addition or subtraction anything away from like this negative 2x value. Okay, we cannot divide. Dividing is almost always the last step. So I have this positive 3 here. I need it to move to the opposite side of this inequality sign, or of that line. So since I'm moving it to the opposite side, I'm going to use the opposite sign. Okay, so positive 3, I'm going to move it by doing minus 3 to both sides. Okay, cancels because I've moved it out. I'm going to bring down my negative 2x less than or equal to 11 minus 3 is 8. Okay, now that we're on a 1-to-1 term ratio here, now I need to get x all the way by itself. I need to isolate it completely. So when two terms are touching, negative 2 is touching that x. That means they are being multiplied. And the only way to undo that multiplication, the opposite of multiplication, is division. So the only way to break this negative 2 and the x apart is to divide them. So I'm going to divide both sides by negative 2. Okay, so cancels. X will now be by itself. 8 divided by negative 2 is negative 4. And now notice I basically switched which side was negative. Originally, like this side was negative, but now on my answer, the right side is negative. I've flipped, okay, that polarity right there. I've flipped which side is negative and which side is positive. Whenever we divide, not add or subtract, but when we're dealing with inequalities and we divide by a negative, we get, if you remember, I always called it a flipper. We have to flip which side the inequality opens up to. So it changes from less than or equal to greater than or equal to. Okay, so this is now x is greater than or equal to -4. Okay, moving on. Okay, a couple more inequalities here. Okay, I have 3 minus, and then parentheses, 2x minus 7. It's less than or equal to 34 minus 6x. The first thing we have to do is look, do we have parentheses or any kind of multiplication in the problem? If we do, we have to do what we call expand. Okay, multiply it out, make it a little bit bigger. Now notice this 3 is not touching this parenthesis right here. Okay, we're not multiplying it to anything. We're not using it yet. We're just going to drop it down. What is being multiplied into the parentheses is this negative sign, which is the same as -1. We're just multiplying that negative into the parentheses. So -1 times 2x is a -2x. -1 times -7. Okay, negative times a negative is a +7. Okay, now we drop the parentheses because we've multiplied into everything that we need to. This is less than or equal to, and I have 34 minus 6x. I don't have any parentheses on this side, and notice I don't have any like terms. So we just bring it down, 34 minus 6x. Now, whenever I have multiplied stuff out on one side, I need to check, did that leave me with any like terms to combine? So like terms are, okay, constants. Constants are just number values that do not have any variables. Constants can go together, and then values or terms that have the same variables and exponents can go together. So here I have 3 and a +7. And notice they are on the same side of this line. I'm not using opposite signs to put them together. Okay, I'm not moving or subtracting in here. They're on the same side. So I'm putting together these like terms. 3 and +7 make 10. And then I have -2x, and there's no other x's on this side of the line. So there's no like terms to combine it with. So we just bring them down, -2x. It's less than 34 minus 6x, which we already knew there was no like terms on that side. Hey, so now we're to the point where we need to get x's on one side of that line and constants on the opposite side of the line. And inequalities should always be solved with x on the left, even if that makes it negative. So I want to identify my x variables. Okay, I won't need them all on this left side. So that means this -6, okay, he needs to come over to this side over here. So this is a -6x. Because I'm going to the opposite sign, I have to use the opposite sign to move it to the other side. I'm going to add 6x to both sides. So it cancels it from the right, and I'm just going now -2x plus 6 to give me +4x. And then I'm just going to keep going with this. Sorry, that was a really ugly line. I wonder if I can. Oh, I can. Great. Okay. Now I need my constants. Okay, my constants are 10 and 34. I need them all on the right side. So this 10, he needs to go over to the other side. So notice he has a negative after him, but not before him. So this is a +10. How do I move a +10 to the opposite side? I use the opposite sign, a -10 to both sides. So 34 minus 10 is 24. And I'm just bringing down that inequality, less than or equal to. So now again, I have my variable term isolated with only a coefficient in front of it. 4x is less than or equal to 24. What do we do now? Okay, 4 and x are touching. That means they're multiplying. Okay, so we undo multiplication because I'm trying to move this 4 to the opposite side of that line. So I have to use opposite operations. So opposite of multiplication is division. We're dividing both sides by 4. So x is now isolated. 24 divided by 4 is 6. And I do not need to flip the sign because I did not divide. Okay, this number on bottom was not negative. It was positive. So if I don't flip, and again, that negative and positive stuff, if I'm not dividing or multiplying by negative, I don't need to flip the sign. All right, moving on to number 12. It says express the following using positive exponents. So what we have here, we have 5a squared, b to the negative 3, c to the negative 4th. All of that is being squared. In Algebra 2, and a lot of times in math, we just are kind of prejudiced. We do not like negative exponents. Ooh, bleh. We like to write them as positive exponents only. I guess we get kind of cliquey. Anyways, so what you should do is you should look at and see like what kind of rule are we doing here? Are we just combining like terms? Are we doing product rule, power rule, quotient rule? What is this problem asking me to do? Now I look at it, I don't have two sets of parentheses touching, but I do notice I have one set of parentheses and then I have an exponent on the outside, which is power rule. Okay, so power rule tells us the regular number does the regular thing. The regular number here is 5, so it will be raised to the power of 2, but then power rule means to multiply our exponents. So for a, I have a 2 times 2, which is 4. Now for b, even though this is a negative 3 inside of the parentheses, I still can multiply with negatives. That doesn't change. I'm going to do negative 3 times positive 2, which is negative 6. For c, I have negative 4 times positive 2, which is negative 8. So go ahead and apply whatever rule it is that you are supposed to apply. And then when you get done doing that, then you move any negative exponents. But let's simplify. 5 squared is 5 times 5, which is 25. Okay, so we have 25, a to the 4th, b to the negative 6, c to the negative 8. Now, negative exponents don't have anything to do with negative value, actually. Negative exponents just mean, hey, I don't like the place that I'm at. I actually want to move from, if I'm negative in the numerator, it means like I want to move down to the denominator. I like it better down there. Or if your negative exponent is in the denominator, it doesn't like where it's at, it wants to move to the numerator. Okay, it's about location change. It's unhappy where it's at. So these two values want to move to the denominator, but I have a little catch. I don't have a denominator in this problem. But guess what? Any number can be turned to a fraction without losing value if we place it over 1, right? Dividing by 1 doesn't change its value. So I like to show it. When I need to move things to a denominator that's not there, I make it a fraction by putting it over 1. And then I move anything and everything that has a negative exponent touching it to the bottom in this case. So both b to the 6 and c to the 8, they want to be positive exponents, but they can only do that if they're in the denominator. So I'm going to kind of move backwards here. Now notice 25 and a to the 4th don't have negative exponents, so they get to stay where they were at, 25a to the 4th, over b to the positive 6th now, c to the positive 8th. We took those negative signs off once we moved them. This is what they should be. They're happy like that, and we like them to be happy. Remember, positive could mean happy, so let's leave them in the place where they are the happiest. Okay, so number 12. Okay, we're going to practice this negative exponent rule by using using different rules in the problem itself. So on 12a, I have 6x to the negative 8th times negative 3x to the negative 3 power. Okay, now times in the problem. Okay, this is going to be product rule. So my regular numbers do the regular thing. 6 times negative 3 is negative 18. I only have one type of variable, which is x. Okay, so keep that base, but what do I do? Remember, I have negative 8 and negative 3. The problem has times in it, but we do not multiply. It does something different. Our exponents do something different than what the problem is telling us to do. We're adding. So what does negative 3 and negative 8 make? It makes negative 11. Okay, I need to simplify this. I can't have any negative exponents in my final answer. So I need to think of this as being a fraction of over 1, and I'm moving things with a negative exponent. Now, does that mean that I'm moving negative 18 down to the bottom? Okay, no, it doesn't. This negative sign right here is not a negative exponent. It's a negative coefficient. It's a negative number value, so it stays. What we are moving here is x to the negative 11th. He's negative up here. He wants to be positive down in the bottom. So we leave negative 18 in the numerator, and we put x to the 11th in the denominator. And that's our final answer. Okay, number 12b. Okay, I have 3rs to negative 3 power being raised to the negative 4th power on the outside. So notice I have a negative power, but I have this power on the outside of the parentheses, so this is power rule again. So my regular number 3, I'm going to raise it to the negative 4 power. Okay, and then for each of my variables inside, I'm going to multiply their inside exponent to the outside. So r1 times negative 4 is negative 4. And then for s, negative 3 times negative 4 is positive 12. Okay, negative times a negative is still a positive. Okay, that kind of math does not change. It's really awesome. Okay, so be consistent. Now, what is 3 to the negative 4th power? Okay, this is not okay, a negative value. It has a negative exponent, just like r to the negative 4th does. It means, hey, please move me to the denominator so I can be positive. Remember, I always think that these things are talking to us. So both of these things need to move to the denominator. So that would make this s to the 12th, okay, on the top. It's the only thing that gets to stay. And this would now be 3 to the positive 4th power and r to the 4th power. Okay, I moved it, and moving it made this exponent positive, just like it did with our variables. That didn't change. What is 3 to the 4th power? It's 81. So this is equal to s to the 12th power over 81 r to the 4th. Now, if you did type in just into your calculator, okay, lost my pen. If I just typed in 3 to the negative 4th power, that is 1 over 81, okay? Negatives want you to take the reciprocal, okay? I haven't used that word yet, but reciprocal does mean to flip-flop numerator and denominator. So 3 to the 4th power equals 81. 3 to the negative 4th power would flip-flop that reciprocal it to be 1 over 81. All right, so we'll be practicing that a lot this year as well. And let's see, I need to hurry because I don't know if this video will upload. Hey, 12C here. Okay, I've got quotient rule because I've got a fraction. I need to simplify negative 9 over 54 because my numerator is smaller than my denominator, so that's just going to simplify as a fraction. Okay, so what I have here is fraction. I've got negative 9 over 54. Okay, that is negative 1/6. So I'm going to leave negative 1 in the numerator. If we have negative fraction, we leave the negative with the numerator. 6 is in the denominator. And now I'm going to teach you a little shortcut that I like to do when I'm dealing with simplifying with quotient rule. We do subtract top minus bottom, but look, for r, if I do 2 minus 5, I'm going to get negative 3. Okay, because we are canceling on a 1-to-1 ratio, okay, I don't want to have to rewrite this lots of times. If there's 2 r's on top and 5 on bottom, and we cancel 1-to-1, okay, meaning I have 2 r's on top, that's what r squared means, and 5 on bottom, that's r to the 5th. Okay, this is another way of writing r squared over r to the 5th. And then I cancel on a 1-to-1 ratio here, boom, boom. I'm left with no r's in top and 3 r's in bottom, which is r cubed. So I like to subtract, and I think, okay, I'm subtracting these, yes. But if I do top minus bottom, I'll get a negative, and then I'll have to move it to the denominator. That's like a lot of extra steps. So I look, they have to stay where the most amount are. The most are in that denominator. So I'm going to be left with r's in the bottom and then subtract 5 minus 2, which is 3. Okay. My s's, why does it keep changing? Okay, s's, I have more. I have 6 s's in the top. I have 2 s's in the bottom. There's more in the top, so I'm going to be left with s's in the numerator. And then subtract. 6 minus 2 is 4. So s to the 4th in the numerator. Then my t's. I have 4 t's in the numerator, 8 t's in the denominator. There's more t's in the denominator, so that's, after I subtract, that's where they will be located, and then 8 minus 4 is 4. And I like that little, it's not necessarily a shortcut, but it's kind of combining steps so that I don't have to deal with negative exponents. Okay, so just think, like when we're canceling out down here, canceling 1-to-1, so where will the leftover be located? Top or bottom, and then do your subtraction. Okay, last type of example, we have absolute value equations. Okay, if you were with me for Algebra 1, we had this whole story about, absolute value looks like, poor little x plus 2 right here. He's in jail, and he wants to get out of jail. But when he gets out of jail, he has two choices. He could choose to be positive or he could choose to be negative. Okay, absolute value, okay, gives us two answers every time, unless we get 0. But we have to solve this by first isolating what's in the absolute value bars, which is, okay, on the left, I only have absolute value bars, x plus 2. So if I had anything like outside the absolute value bars on this side of the equal sign or in front of it, I'd have to move it away. But I don't have that in this problem, so we're okay. Okay, so what we're going to do, once it is already isolated, we're going to take that x plus 2 and we're going to write it down 2 times because, like I said, he's getting out of jail, this x plus 2. Notice he's getting out of those bars, so he's getting out of jail. That was the example we used. So he had two choices. He could choose to be positive, so he could be positive 5, equal positive 5, or he could choose to be negative, go back to his bad choices, negative 5. So now I've set up 2 different problems that I can solve. All right, and this is just a one-step equation right now. X plus 2 equals 5. What plus 2 equals 5? Well, we could solve real quick by isolating. And we would say x is equal to 3. Okay, okay. We also are saying x plus 2 is equal to negative 5. What's this other value? We're still going to subtract 2, but now we're subtracting it from negative 5. Negative 5 minus 2 is negative 7. Okay, so our 2 values here, okay, we could write them in parentheses like this, but you don't have to. 3 and negative 7. Okay, moving on. What I'm talking about is we have to isolate. Okay, see this absolute value of y? He has to be all the way by himself. All the visitors, we said anything outside those bars on the same side, the equal sign, that value was a visitor. And guess what? People can't get out of jail if they got visitors in there with them. The visitors have to leave first. That's what we talked about. So I got this negative 8 who's got to move to the other side. Well, I'm moving it to the opposite side of this equal sign line. So we use opposite operation. We add 8 to both sides to move. So that I'm left with absolute value of y is equal to negative 5 plus 8, which is positive 3. Now, see how this is isolated now? It's the only thing, okay? Out. Now, I take what is inside exactly as it is, y, and I write it down twice. And he has now 2 choices. He can choose to be equal to the positive value on the right side, so positive 3, or choose to equal negative 3. Okay, now at this point, I would think I got to isolate my y value, but notice these y values are already isolated. So this one's actually done. It was pretty nice and easy after doing that. So our 2 answers here are negative 3 and positive 3. Notice I use braces because this is a solution set for x. It's not, if I use parentheses, I would be making an xy coordinate that I'd want to plot. And we don't want to do that at this point. Okay, let's do, oh goodness. Let's just do 13C. Because I'm really hoping this video will upload. Might be too long. All right. Absolute value problem. Now, who's in jail? That's the question. 4n plus 8. He's the guy behind bars. We want to bust him out of there because we really like him. We want him to have a second chance, but he can't get out till his visitors are gone. So who are the visitors? The visitors are 7 and negative 6. Now, the order in which the visitors leave is very important. It's like solving an equation. If I thought of this as 7x minus 6 equals 106, if I think of this 4n plus 8 as my variable, well, we know that we should move any addition or subtraction first to isolate, which is the same thing in this type of problem. I'm moving the negative 6 first, the 7 second. Order matters in math. Okay, so how do I move a negative 6 to the opposite side? I add. I use opposite operations. So I'm left with 7, absolute value of 4n plus 8. It's equal to, oh, not that. Okay, 112. Okay, now my second visitor, 7, it's his turn to leave. Now 7 is directly touching that absolute value. That means they are being multiplied. How do I undo multiplication to move it to the opposite side? I use the opposite operation, so I'm dividing both sides by 7. So 112 divided by 7 gives me 16. It cancels from the outside. Notice I'm not touching any of this on the inside. Not allowed to, until he's out of jail. So we're bringing down absolute value of 4n plus 8. It's equal to 16. Now look how beautiful this is. Oh, let's see if I can use a highlighter. Okay, this 4n plus 8 has now been isolated. I don't have anything here or here. So that means that we can take what is inside. Okay, we're busting them out of jail. We're writing down 4n plus 8. I'm writing that down 2 times. Put an equal sign. And 4n plus 8, he can choose to be positive 16 or he can choose to be negative 16. It's up to him when he gets out of jail. You always have a choice. Now we're solving for n. Okay, so find my equal sign. Okay, I need this two-step equation, isolate n. So first we're going to subtract 8 from both sides. So we have 4n is equal to 8, and then we divide by 4. So one of our answers is n equals 2. I'm going through the same exact steps for my second choice, negative 16, but I will get a different answer because when I subtract 8 from negative 16, I get negative 24. We're saying this is equal to 4n. See, same thing. Still dividing by 4, but negative 24 divided by 4 is negative 6. So my two solutions here for n, my solution set, it could be negative 6 or 2. Usually we write least to greatest. Okay, so that was Algebra 1 review, day 1 for Algebra 2. Good luck.